So, so first of all, I would like to thank everyone for dedicating time and joining in this session. Uh, in this session, we will talk about a Power BI software, but more important than that, how we can utilize this software in oil and gas industry for data analytics, visualization, and even some more. My name is Nashat Omar. I've been working in oil and gas industry for more than 11 years, and I will be your presenter today. This webinar is in two parts. Part number one is going to be today, and part number two will be tomorrow. Today, we are going to take a look at the basics of Power BI and basically how Power BI can be utilized to create various visualization and analysis. Also, today, we're going to take a look at how we can create time series analysis in Power BI. Time series analysis is a part of machine learning tasks or a statistical learning task, but we can easily integrate that with Power BI. Plus, I will show you how to create a production decomposition for a production parameter based on decomposition trees. So this is what is going to be covered today. And for day two, please make sure to join as well, because we're going to cover trend analysis. And I will show you how to do some basic machine learning tasks using Power BI, for example, clustering. So without further ado, let's go ahead and start the session. So what is Power BI? Power BI is relatively a new software in the Microsoft Office package. Although it's not installed alongside with the Office, you have to go ahead and seek that manually in Microsoft website, but the software is free. This software is basically used to create analytics, visualization, and drive insights from your business data. So basically, this is what this software is about. This software is in a category called business intelligence category, or the BI category, alongside with other softwares, for example, Google Analytics, Spotfire, Tableau, and many, many other softwares. But Power BI stands in strong position because Power BI is free, it's easy to learn, and it's extremely powerful. So if we ask ourselves what Power BI can do, it can do many, many things. So the first thing it can do is actually it visualizes data. Data visualization is a very required task nowadays, especially with the vast amount of data we started to get each and every day. We can convert our data visualizations and combine that with data analysis so we can derive insights from our data, basically understand how our data is performing, how our assets are measured, or how can basically we know if our asset is doing good or doing bad. So this is basically what an insight provision means. Plus, once you have those visualizations and those analysis created, you can convert both of these into something called a dashboard, which is a collection of visualization and other components. Basically, the dashboard tells you how good or how bad your business is doing. You can also use Power BI to monitor KPIs. KPIs is usually just a single number values. Up usually means good, down usually means bad, unless you're talking about parameters, for example, like water cut, up is always bad and down is always good. Plus, Power BI actually allows you to create standardized dashboards and standardized interface that you can actually publish and put on the desk of each and every engineer. They can use in order to create the same insights and visualizations that you're doing. Basically, Power BI is an ecosystem that's usually applied to a whole industry and a whole team. And even more than the team, we can escalate this and make it applicable to a full organizational scale. So why you should learn Power BI in the first place? If you're new to Power BI, so let me just give you a few points why you should learn this. First of all, Power BI helps you to understand your business data. Nowadays, we have lots and lots of data, but usually we do not understand what these data means, or from the vast amount of data, actually we lack the time to analyze and go through these data. By the help of the statistical engine that's built inside Power BI, we can actually create very, very useful insights and a statistical representation of our data. Basically, it will help us understand what's going on. We can use Power BI to transform, load, and integrate our data. Using Power BI, you can drive decisions that are based on data. Plus, if you are not making those decisions, you can actually facilitate making those decisions by creating analysis and visualizations that are really, really easy to understand and comprehend and probably present to the line management. Power BI can allow you easily to track assets. So basically you will know what your wells, what your equipments are standing at. Are they doing good or they are doing bad? Plus, Power BI allows you to identify patterns faster because you can leverage analysis plus visualization. So this way you will understand what's happening or which assets are candidate for which part of maintenance or what's happening in your asset. Are they losing production or are they keeping performance? Plus, in my opinion, one of the most important things that you can do in Power BI is actually the learn or the action of learning Power BI is actually the knowledge itself is transferable, meaning that you will only learn it once and you can apply it many, many places in many, many industries. So Power BI in food and beverage industry is the same as oil and gas industry, is the same as chemical industry, it's the same as in manufacturing. Each and every industry is using Power BI, but they are using their own version of data. So in this training, we will be focusing on oil and gas applications and how we can integrate oil and gas data in Power BI. But if you learn Power BI, you can apply it anywhere you want and on top of any data you like. So if we ask ourselves who should learn Power BI should be learned by professionals like you guys or fresher, people who just graduated, or anyone who is in the management can also learn Power BI. Power BI is actually suitable for everyone. It's suitable for engineering teams, specialists. It's suitable for line management. It's suitable for team leaders who just want to see numbers or they want to keep track of the performance of their asset they are assigned to. Plus, it can be used in upstream, downstream, and midstream. So to say, actually, if you have if you have data, you can then use Power BI. So the only requirement to use Power BI is actually the data. If you have the data, then you're good to go and you can start learning Power BI and applying that to your business. These are a few examples of Power BI that we provide in the training. These are actually ready to use examples that are already worked out. For example, this is used for shale gas wells. This example is from North Sea gas productions dashboard. This is an example of operational dashboard. This is an example of pipeline maintenance or pipeline integrity dashboard, basically made for pigging. Many, many more examples can be done in Power BI with ease, and you can control the complexity of these types of solutions. Before we move forward with the visualization, I want to just tell you that Power BI is not just a software. Power BI is an ecosystem. An ecosystem means it's actually a piece of software that's made up of many, many components. And these components is separated over a wide range of users. So the Power BI that we usually use is called Power BI Desktop. This is the one. Power BI Desktop is a free version of Power BI that you can do almost all the same thing that you can do on the paid version. Other versions of Power BI is basically dedicated for corporates to buy as a bulk license. We have the Power BI service. Is basically a service that a company runs. Think of this as a report generator and something that you keep your report with. You can have Power BI on the mobile Basically, Power BI on the mobile consumes whatever you have been created by Power BI desktop plus the service. And we have Power BI report builder, we have Power BI service, we have the embedded Power BI. So basically all of these are the same thing, but starting from point 2 and going downwards, these are all paid services. So if your company is starting to use Power BI and you guys are just in the trial phase, most probably you will start with Power BI desktop. If your company or your corporate decides to cash in and purchase Power BI, you will still be using desktop and then plus those services that comes along with it. Let's say that Power BI desktop is the main application that we will use in order to consume all of these things. Where can you download Power BI? Power BI is a free software. There's 2 locations you can download it. Either you go to Microsoft website, or you can download Power BI from the Microsoft store. You can choose whichever one seems convenient. In Power BI, the main thing that we usually do is data visualization. Data visualization, we have many options in Power BI. We have elementary visualizations, we have advanced visualizations, and we have things in between. But in the first place, why we are actually using visualizations? What is wrong with the tabular data? Usually, the data that comes from the field looks something like this. It's usually tabulated. So this is tabulated data. What's wrong with these types of data? So the problem with this is actually the human eyes is not able to keep track what change is happening in the data, because you will do something called cognitive load, or your mind will start working really hard to understand what's happening in the data. This is how humans' brain is wired to work. But once we convert these data into visualizations, now suddenly our brain starts to recognize the patterns, and it's going to be much easier to understand, and it's going to be easier to comprehend. Basically, this is the basis of all business intelligence tools, which is to make the brain work less and focus more on the analytics part of this. So we have many types of charts we can do in Power BI. I can go, by the way, I can go through the slides, but I would rather show you these firsthand in the software itself. So let me just open up Power BI software and show you a few visualizations. So Power BI is a software that's usually installed from the store or from Microsoft website. Once you install the software and you open this up, the software will look something like this. Once you go ahead and load the data from the Home tab, either you choose Excel or you choose Access, or you can choose text, or you can even go ahead and connect that with SQL database if you have an access to that. Once you do these loading tasks, you can save working with, let's say, the analysis and visualizations. Usually on the right-hand side, we have the data pane that contains all the tables. Each entry is corresponding to a table. A table that's basically coming from either Excel sheet, or it's either coming from CSV or coming from text files. We can leverage those and not just load it, you can also create relationships between those. Once you have those relationships in place, you can do wonders with Power BI. Unfortunately, we're not going to go through to these relationships in the free webinar. This is something that usually we cover in the training because it requires some attention. So let's start by creating a very simple chart. That's going to be a linear chart or a line chart. We will open up the visualization pane. By clicking on it, it will start to expand. We will select the line chart, for example. And once we select the line chart, what we can do is we can start populating these with data. For example, let's pay our attention to the production data. Once we click on the production data, this table will expand. Once the table expands, actually, it will start showing us all the columns that exist within it. Okay, so one of the columns that are missing is actually the gas oil ratio. So we have to calculate that, for example, if you want to visualize it. That's why Power BI, it's really, really easy to use and it's really powerful. It allows you to create calculations with ease. So let me show you how we can add a calculated column to this. So we will right click to this and then we will select new column and it will ask you to enter the equation. So the equation for gas oil ratio is very simple. First of all, let's give this a name. So let's call this GOR equals to. So the equation for this is going to be gas production over oil production. So it's going to be as simple as this. Once we have this already finished up, we will click on commit on this green check. And believe it or not, you have created a new calculated column. And this new calculated column, actually, it does not reflect on the actual file or actual source file. It's only kept in the software. In order to plot this gas oil ratio, what we will do usually is we will drag this gas oil ratio or any parameter you want on the y-axis. And on the x-axis, you can visualize a few things, but mainly we visualize dates. So we will drag and drop the date on the x-axis. So we will have this looking like this. Now, basically what's happening now, it's actually combining the gas oil ratio from all the wells that we have sitting in the data. Now, in order to effectively visualize the gas oil ratio for a given well, what we will do, we need to activate the filters, or basically it's called slicers in Power BI. We will add a slicer on this empty place, and the slicer will be empty. So what is the parameter that we want to filter on? Basically, it's actually the column that contains the well names. So we will drag and drop that. It will basically populate all the well names for us. And we can just start selecting whatever well that seems proper and we want to plot. If you want to add another parameter to this, for example, let's add a water oil ratio to this plot as well, and you're afraid that the scale is not going to match up, what you can do is you can drag and drop the water oil ratio to another y-axis, which is called the secondary y-axis. Now suddenly you have two parameters showing up in the same place. And you can basically just switch on whichever well you want. There is one more thing that you can do with this. It's part of how Power BI is built, is actually you can combine the readings or calculations for GOR and water oil ratio from multiple wells. And you decide, you as the user decide how you want to combine these. Do you want two wells displaying at the same time? Or do you want the readings from both of the wells to be summarized and then plotted for you? So let's select 3 wells. Once we select 3 wells, you can see now suddenly the gas oil ratio now it's starting to read more and more as we add more wells to this. Why this is happening? Because the gas oil ratio and the water oil ratio is actually being summarized, or it's being summed before it's actually presented in the plot. Now, where can we see this behavior? If we click on the plot itself, we can see the y-axis, or let's say the aggregation action for the y-axis is summation of GOR, and the secondary y is actually sum of water oil ratio. We can easily flip this to average or any parameter you want. So let's just set to this to average. Now the GOR is actually the average of all of these 3 wells. And you can basically do this for everything you want. If you're not comfortable by plotting the GOR and water oil ratio, all of them combined in a single value or in a single line, what you can do is you can break up this plot by the name of the well. We will provide a well name into the legend. This will break down our plotting, but first we have to actually delete one of these axes. Either we will keep GOR or we will keep water oil ratio, because now we are going to have many lines. Let's delete the water oil ratio for now and populate the well name as a breakdown parameter. Now you can see that those three wells are not being aggregated anymore. You can also go ahead further and add more wells to this. This is just a very simple part of how we can create visualizations, or how can we actually start to create and get analysis with Power BI. You can also add other parameters next to GR. For example, let's add the water rate next to GR. But once we do that, we can see that GR actually has offsetted the water rate. Now, in order to actually make this work, or make these both of them compatible, what we can do is we can go ahead to y-axis and make sure that this is in logarithmic scale. So let's do something like this and activate the logarithmic scale. Then you can see both of these plots are now just displaying against each other. It's not about only a single plot. You can also have multiple plots at the same place. By just copying and pasting something like this, you can have multiple plots at the same place. Many things can be done with Power BI. One of the things that we can do with Power BI is actually creating time series analysis. The time series analysis can be integrated in Power BI using a very simple script borrowed from Python, because Power BI supports Python and supports the R language. Usually in oil and gas industry, we usually use Python over R, because Python is much easier to understand and comprehend. Plus, the code is easier to read. I have an already worked out example on autoregression. Let me show you what an autoregression is before we even proceed. So let me show you this in the pane plot. So let's say we have a time-bounded data, which is usually the type of data that we have in Power BI. So let's say that we have time on the x-axis, and we have any form of parameter that actually you're keeping track of. For example, let's say that we want to work with water oil ratio, because it's usually really hard to predict these types of parameters. Let's say that the water oil ratio has its own signature, and let's say it has its own pattern with time. Usually these types of parameters are really hard to predict, especially with the classical equations. What we can do is either we approach this problem by fitting a straight line in Power BI, something like this, and then we extrapolate this portion of the line. So this portion is going to be extrapolated. So once we extrapolate this, we can get predictions for the upcoming or the future time. So this is going to be the future time. So this is going to be the future line. Better yet than this is actually to use that statistical learning, and basically, instead of just creating a single line with a single slope, what we can do is we can create something called an autoregression. An autoregression is one of the simplest time series analysis machine learning tasks that you can do. Basically, what it does, it solves for the linear equation, but instead of just taking a single slope, what it does, it takes look back at X number of data. So let's say that we want to take look back at 10 data points. So in order to predict a new data point, we will take a look at 10 data points prior to that, and then we will start creating our predictions. That's why usually we don't have a linear prediction coming out of autoregression. So let me show you how this is done. Those yellow lines or those yellow crosses are the historical data. And this continuous line or this azure line is actually the line that's computed from the autoregression plot or from autoregression analysis. And this magenta line is actually the line for the future prediction. What you can do in Power BI is you can program all of these in few lines of code. If you click on the plot, you will see the code. And in this code, I am fitting 40 points prior, but you can go ahead and fit only 10. Once you fit 10, you will just click on run. It will create a new analysis and visualization for you, plus it will do a new forecast for you. You can predict anything you want. For example, you can fit based on 25 points. It will generate basically a new forecast for you. If you're not comfortable with viewing all the plot at a single step, what you can do is you can only select a proportion of your plot in order to do your analysis with. For example, let's select the 2004 as a starting or a beginning point for our analysis and visualization. So we will just move the date slider like this. And we will set this to 2004. So this is going to be the beginning date for us. We will wait for the chart to load up. There we go. Now this is the new prediction. You can just select any date range you want. For example, let's select a 9 years date range. And this is the prediction for this range selection that we did. Of course, you can go ahead and select multiple wells as well. For example, you can select any number of wells you want, and these wells will be combined inside Power BI, and then it will be provided by the analysis. This is the prediction for this data type. Of course, you can increase the range for prediction and the fitting the data. You can basically do all sorts of things with these. This is one of the examples that you can do with Power BI. Let me show you another example that we can actually use in order to decompose or basically break down a great value into smaller ones with keeping in mind where we are getting these smaller values from. So basically what we usually have in oil and gas industry is usually we will get a number. So for example, we get a particular number, and usually there are many small numbers that actually are contributing to this big number. So this is, let's say, this is number 1, number 2, number 3. And those all small numbers, they all basically contribute to this, either using summation or some form of averaging. So now, in this example, I will show you how to decompose this big number into these smaller numbers. And let me show you how you can do this in Power BI. This type of task in Power BI is done using something called decomposition tree. We will open up a new page in Power BI, and we're going to select decomposition tree. It will add the visual for you. We will maximize the visuals like this. And then now we'll start our analysis. The analysis can be anything you want. For example, let's start with an oil analysis. We will drag and drop oil on top of this. It will tell you that the sum of oil or the summation of produced oil from all of your data is actually 47 million something. So what does this number mean? This number means that the Power BI engine has combined all of these production from all of these wells into just a single value. This will allow us, first of all, to know what is the total of this value, and then we can just break this down by other values or by some form of rule that we will create. Okay. So how can we break down this oil production? This oil production or any parameter can be broken down with many things. So the first thing that we can break the oil production with, or we can break down the oil production, is actually the field that's contributing to this oil production. So what we will do is we will drag and drop the field to this explain by section. Once we do that, you will get this plus sign, but Power BI is still not doing anything. Why is this? Because Power BI is a general tool. It's not built for a particular industry. It's built to be general so everyone can use it. So I will click on this plus sign and I will tell it to explain this value or explain the summation by the field. Once we do that, it will basically show you three entries, three fields, and one of them is of course blank, meaning that we have some lines of data. It's not assigned to either of these. That's why it's showing blank. And in the training, I will show you how to actually to fix these types of issues, basically by transforming the data. And we can see one of the fields is basically contributing to like 99% of the production. Usually, we do not stop at this position. We will add more explanation to these values. For example, I want to know which zones or which production zones is basically contributing in this field. So what I will do is I will drag and drop the zone to the same explain by, but it's going to be below the field. You will see now the plus sign is also visible again. We will do it plus, and then we will continue by clicking on the zone. We can see which zone is now contributing more to this field. By using these types of examples, we can know which zone is basically contributing to pure production. This can help you in deciding which wells can go through workover or which wells can be going to the shut-in position or the shut-in status, and which wells actually are basically penetrating these good-looking zones. You can do the same analysis for water and basically diagnose where the water is coming from, maybe shut down those wells, maybe shut down those zones. If you want to go ahead and further explain these data, we can just drag and drop the wells and then explain the production by the wells. We will click on this plus again, and we will click on wells, meaning that we want to explain which well is basically contributing to these types of production. Those are the wells basically that are contributing to the production. Usually those are sorted from the highest to lowest. There is also a scroll that you can scroll down through all the wells that are basically contributing. Plus, if you click on any of these zones, it will update the chart to view only the wells that are basically corresponding to the zone. We can see some zones have only few wells are penetrating. This is basically how you can create a production breakdown, or basically any parameter breakdown using oil or using any parameter you want. Now, let's do one thing. We will minimize this plot, and I will create another production decomposition, but this time I will do this for the water production, because usually water production is a source for a problem in oil and gas industry. So I will add another decomposition tree. I will use the produced water as the parameter that I want to analyze. And in order to explain this, I will explain this by field first. So let's select field. And I will explain this by zone. And I will explain this by the end with wells. So now let's start adding our plus. We can see we have 750 water produced from all of these fields. So if you basically do the math on this, you will find actually the average water oil ratio for this is more than 1.5 or 1.6. So it's basically you're producing 2 barrels of water for each barrel of oil. Let's start explaining this water by, for example, by the field. We can see both fields are contributing almost equally. We will start again by selecting the zone. Now we can see which zone is actually contributing too much into water production. We can also select the field and to reflect which zones are contributing in that particular field. Of course, we can add those wells as well. Once we add the wells, we can actually for sure know which well is actually contributing the most to the water production. By adding these types of visualizations and creating these simple calculations, you can get great insights from your wells and from your assets. Now, one final example that I will show you today is how we can actually visualize well logs using Power BI. The truth to be told, Power BI is not designed to view well logs, but with a smart move and knowing how we can do that, we can actually implement that successfully. But before we do that, let me show you what a well log looks like if you don't have an idea. So usually a well log is an ASCII file that's basically captured and it's measured from wells, and it's generated and saved inside an ASCII file, which is something similar to a text file, but it has its own structure based on some standard on log acquisition data structuring. So usually the log files looks something like this. It ends with the last file, or sometimes it can end with the list file. We can open any of these files using Notepad. This is what a log file looks like. It's a pretty well-structured file, but it's usually read sequentially from top to down. And in the final section, we have all the data that are relevant to the well log. Usually in reservoir engineering, what they usually do if they lack the tools to read such a file, they will actually copy this section and then paste it in Excel sheet. This is something legit and you can do, but there are lots of caveats and there are lots of limitations of this process. Even better yet is you can create a simple Python script inside Power BI in order to start reading those well log files. So let me show you how we can structure such a project. What we usually need in these types of projects is actually a table that contains all the well names plus your file link or where does this file exist. Now, how was this generated? Although the process seemed cumbersome and it seems hard to do, but there is some Python script that can actually help you to create these and update these. So you will just create this once and then it will automatically update itself once one of the well locations has changed or new files has been added. So you don't need to keep track of everything manually. So this is usually done automatically. Once we have this, what we can do is we can do many things. We can create a well log visualization for single well by selecting any of these wells, and you can select any parameter you want. You can also select other wells. Once you select other wells, the well log visualization will reflect on that. You can select multiple wells, but selection of multiple wells, I have created another dashboard for this because the way it works is different. You can select any well you want, and by selecting the well, what it does, it's basically, it will read or it will take the name of the well, and it will read whatever file that corresponds to this file path. So once you click on the well log, it basically, you'll see the code that's responsible for this. And all of these actions and all of these customization is only under 20 lines of code. If we deleted all the redundant ones. Not only that, you can also customize this plot to your likings. For example, if you don't want the gamma ray to be viewed as this type of plot or as this type of line, maybe we want to do this as a green or red or black or whatever line we want. Let's do this red. If you want to view this as a dotted line, you can also do that by changing the code. Once you do that, you'll click on run. And there we go. Now the gamma ray has changed. As you progress forward, now you can see all the gamma rays and all the well logs that are generated will be changing from now on. Why is this? Because we changed the settings of this well log visualization file. Now, let me show you a slightly different example, although based on this one, is actually the multi-well log. Basically, we have the same wells, we have the same visualization, except for the resistivity. I omitted the resistivity because the resistivity actually is 3 curves in one, which is the shallow, the intermediate, and the deep one. So I omitted this one because we will get too much curves, but you can just make this also possible. What we can do in this section, the same code now will run on multiple wells that you can select. For example, we can select 2 wells, and by selecting 2 wells, we will load 2 LAS files inside the Power BI software. So what Power BI software will do, it will pass all of these files inside Python, and Python will basically just load these for you, and you can just compare the readings from multiple wells. You can make even things more simpler than this by including only a single track. For example, you can only include gamma ray, or you can only include the porosity log if you have or that already calculated, but you can select as many wells as you want. And you can make this as simple as you want, and you can make this as complex as you want. So these are basically one of the projects that we will go through for more than 1.5 hours during the training. And basically, we will teach you how to create such a thing. You can do lots and lots of things with Power BI. One of the things that you can also do with Power BI is actually you can create a visualization for your pressure surveys using contour plot or using any type of plot you want. You can also visualize these using maps, or you can visualize heat maps in Power BI. So let me show you how you can do that. For example, I have pressure survey readings. I will create a map. In this map, we need to add a few things. We need to add the latitude, the longitude, and basically whatever values that you want to color based on. So let's say that we want to color based on the pressure. If you have other parameters, for example, water saturation, porosity, anything you want, or oil density, you can do that as well. I will be using this pressure as the value, and I will make sure that the longitude and the latitude are all set in place. Once we do that, now we will start to get those dots are visible or showing. What can we do next is instead of just having those bubbles, we can convert those into actual colors or into actual color codes that represent the minimum and the maximum value of these readings. We can go to settings and activate the heat map. Once the heat map is activated, we can divide those colors based on any color set we want. So let's select the yellow, or sorry, let's select the red or the orange, yellow, and let's select the green to denote the maximum pressure that we have. And it will basically show it something similar to this. You can increase or decrease the radius, the range, or anything you want. Basically, this is how you can visualize those data points as a heat map using the aerial or using the satellite maps as it's fetched from the source. You can also change the type of the map to be aerial or any type of map you want. Now, this is an aerial map that's close or similar to the satellite map that we can have. Plus, what we can do is we can also add analysis next to this map. Because this table contains many, many important parameters, what we can do, we can just create a summary report for whatever we are seeing in the map. For example, I will add a table. In this table, I will add whatever the geological source for these pressures are. For example, I will just visualize the geological period. For example, we have the Cretaceous, we have the Paleozoic parts, and we have, of course, we have the Mesozoic as well. What we want to know now from this pressure map that we see, what is the average pressure that we are getting from Cretaceous? What is the average from Jurassic, or let's say from the Mesozoic, and what's from the Paleozoic? What we will do is we will drag and drop the pressure next to this geological periods. And basically what we will get is we will get the recommended aggregation from the Power BI engine, which is the summary. Usually the summary for pressures or the summations of pressure, it's not very logical in oil and gas industry because, well, you cannot sum the pressure. What we need to do is we need to either convert this to average or something else. So let's work with average for now. Once we work with average, now we have a nice summary of all the geological sequences, or let's say all the geological periods, and what is the average pressure corresponding to that. What you can do is not just stop there, but you can add one more table. That particular new table, what it does, it will only show you whichever geological period you want to view the pressures for, because now we have averaged out everything. Maybe you want to see more details. So what we will do is we will create the same thing. We will add the geological periods. We will add the pressure next to it. And instead of just summarizing everything, I will select do not summarize. So once I go ahead and select the Jurassic, I can see what values are basically contributing to this 10K pressure in the Jurassic. We can see all of these measurements are happening in the Jurassic. Of course, they are just sorted from the minimum to maximum. We can do the same thing for the Cretaceous. We can do the same thing for the unknown. So we can see basically we only have one readings in the unknown. So basically it's making this the total. And we can also do this for the Triassic. If you don't want to see the average pressure, maybe you want to see the maximum pressure, I will not change anything. I will just add another pressure next to this and make sure that this is set to maximum pressure. So now this is the maximum pressure that's basically we have read in the, for example, in the Cretaceous, which is 14,832, which is exactly the last value in the Cretaceous table entry. So actually, many things that can be done in Power BI. Power BI is very fun. It's very helpful for anyone in any industries, and certainly it's very helpful for oil and gas engineers working upstream, downstream, and midstream. Thank you so much for joining in today's session. Tomorrow we will work more on Power BI, and I will show you basically how we can drive more analysis and insights using Power BI software. So over to you.